Okay, so the last set of equilibrium calculations we're going to look at is when we have to use the quadratic formula. This question matches page 146 of our pink book. We start with our KC equation first, so it will be PCl3 square brackets to the power of 1, Cl2 square brackets to the power of 1, all over PCl5 square brackets. If you read through with the question, it is telling us that we have a Kc value. It's telling us 1 mole of PCl5 is heated in 10 litres and calculate the equilibrium concentration of all components. So we know that when we have a Kc value that it's either going to be the square root method, or it is going to be, we have to use the quadratic formula. Okay, so we set up our question with PCl5, PCl3, Cl2, initial concentrations. We know we're using the ratio to determine the values of x, which will be the amount something will decrease or increase. So as the ratio for the equation is 1:1:1, all of the x values are worth 1. Our question is telling us that we have 1 mole of PCl5 in 10 litres. We need to make sure that we have everything as in moles per litre. So I do the division at the start. We always know then that our products are always 0 initially. In terms of equilibrium, I can write 0.1 minus x for PCl5, and these guys are going to increase by x. I have no other information, so I have to input all of this data into my Kc equation. So it now is going to look like x by x here is the same as writing x squared. It is going to be all over 0.1 minus x, and that is going to be equal to 0.04. So straight away, even though I have a square root, I could square root this. I have nothing here, so I can't square root this, and that's the giveaway for using your quadratic formula. Before we can get to that point, we have to rearrange this so that it will look like an ax squared plus bx plus c. So the first thing that I'm going to do here is move this to the other side, and to do that I have to multiply both sides by 0.1 minus x. So multiplied by 0.1 minus x. These guys will cancel out, so I will be left with x squared is equal to 0.04 by 0.1 minus x. So I need to do this multiplication within on this right hand side. So when I do this, I get 0.004 minus 0.04x, and that has now x squared on the other side. So I want to remove all of this and put this on the other side of my equals line. So to do that, we just make an addition and a subtraction. So now I will have x squared plus 0.04x minus 0.004. Excuse me. And that is equal to 0. So I'm now set up as a quadratic equation. So in this instance, we have to work out what a is equal to. So a is equal to 1, b is equal to 0.04, and c is equal to, c is equal to, I can do this now, is equal to minus 0.004. So the quadratic formula that we're going to use is in the maths tables, and literally you can put this into your calculator. So it is minus b plus or minus the square root of b squared minus 4 times a C, which is minus 0.004 all over 2. So if I was doing this, I would do it the first time around as the plus, get my answer, do it second time around as the minus, making sure everything matches what it looks like here in my calculator. When I'm done, I get 2 answers. So from the plus equation, we get 0.463, and from the negative version, we get 0.086. We have some rules for this, so we always ignore negative values, or we ignore very large values. So there's no very large value in this. It is this one that is going to apply. So we're going to ignore the negative value. So we've solved for x, and in this case, x is equal to 0.463. Now, if we scoot back up to our question, it asked us here to calculate the equilibrium concentration of all components. So we're now going to take this line and rewrite it down at the very bottom. So at equilibrium, PCl3, Cl2, we said we had 0.1 minus x, we have x and we have x. So we have 0.1 minus 0.0463. We have 0.463, we have 0.463. So this will be equal to 0.0537. So these are my final answers for that particular question.